Now, I don't know how much of this you've studied in Calc 1, if your teacher hit it very much, or if they didn't hit it at all, because it is technically in this section. So I'm actually going to write down Math 65 and 66, because I'll probably show this video to my students later on after they've learned integrals. This is on 6.9. We're doing hyperbolic trig functions. And they're called hyperbolic because they satisfy the equation x squared minus y squared equals 1. And we got two primary ones, and the rest all stem from them, just like the trig functions. The way we indicate a trig function is hyperbolic is we add h to it. So cosine becomes cosh. Sounds like gosh. And this is e to the x plus e to the negative x over 2. And the hyperbolic sine function, pronounced sinh, is almost identical. We have e to the x, we have e to the negative x, we have a 2. The only difference is it's negative. This one's like the average of e to the x and e to the negative x. I don't have any grand insight for you on hyperbolic sine. They have a lot. Well, I'm not going to go with a lot. They have a lot. They have a few real life uses. There's catenary arches and bridges. It's the trajectory of a satellite. Doing a planetary or lunar slingshot. Where it enters, it goes by the outskirts of the planet. It gets pulled in just enough by gravity to accelerate. And that makes it accelerate fast enough to escape gravity. And if it's done right, they can actually like gain speed. There's applications in special relativity. You've seen many in real life. You probably never thought of them like that. The ones you've probably seen the most, most of the ones you see are related to cosh. And they look a lot like parabolas. In fact, when you look at it, you might go, that's a parabola. And I'm going to click over to the book and show you the map, or that not maps, the graphs of them, because it's just quicker. And then I'm gonna show you just how many fucking formulas there are. And we're not gonna go over all of them, but we will go over several of them.
They put a slingshot thing in the margin.
Did they? Huh. It's been a while since I've seen The Martian.
There was one movie where they were doing the slingshot around a star and they traveled through time. So, you know.
You'll see how there's a lot of
I
sci-fi
forget
shit
which
out there.
movie that was though. That I think so. No, Interstellar was the one with the wormholes, wasn't it? Yeah. It was one of them.
Now the show, I think that is my favorite sci-fi. That's probably older than everybody in this room. Firefly. I had never even heard of Firefly until I was watching Big Bang Theory a long time ago, and they were bitching that it was taken off the air. And I watched it, and you would not think that like sci-fi, space travel, and cowboy western blend together well, but they fucking do. They blend together really well. It's like there's only I think one season of Firefly, and then there's a movie called Serenity. But it's really fucking good. All right. Wait, some folks are still right. I don't want to raise
Depends
it.
on the.
Okay. I will change this over while you're doing that. That's not what I wanted. There it is. So this is Kosh. And this is the Gateway Arch in St. Louis. And it is an inverted hyperbolic cosine. It was modeled to be that way. And you can take it's a weird elevator if you've never been to St. Louis. You can go up into it and go up to the top and like look out over the city. There's a TV show that had it in it where it was like one of the sole surviving structures when the world was destroyed. And they used it as base. I forget what that was called. Cinch looks like so this looks like a little like x squared going up. This is a little like x cubed, and the other ones like this one looks like 1 over x. Bunch of weird shapes. Let's see if they got a few more pictures. Telephone wire makes a hyperbolic curve. You'll see bridges and shit have that. Okay. While I'm doing this, look at all these fucking formulas. That's one set of formulas. There's another set. Like this, you learn one way, you go the other way because derivatives and integrals are opposites. But that wasn't it. There's more. There's more. There's more. Okay, back to the lecture at hand. Oh, share, change to screen, hit dot cam, hit share. There we go. So the other 4 that we haven't talked about, the hybrids, Tanch. Whoa. Hi, video folk. When I click back and forth, it changes to this camera rather than going back to the document camera like it's supposed to. We have Tanch X. Guess what that's composed of? So we have e to the x minus e to the negative x over e to the x plus e to the negative x. Cough x or hyperbolic cotangent is, yep, 1/10. And then we have our dysfunctional ones. Chord, secant, and cosecant. Sech, or hyperbolic secant, of course, is 1/cosh. And I'm not even gonna try to say this one. 1/sinh. Yeah. I've learned. It's taken me a while, but I've learned. Someone raises their hand, first thing is check if I wrote something stupid. I figured that one out before you had to tell me. Remember your beloved cosine squared x plus sine squared x equals 1. So non-hyperbolic. Hyperbolic. So close. It is cosh squared. Minus sin squared. Yeah. In fact, if we have the coordinates cosh t, sinh t, like it's parameterized function, then these coordinates satisfy x squared minus y squared equals 1. And that's why we call them hyperbolics. Probably why we added h to them. That, and they look so much, they behave, all their formulas are so much like, creepily like, the trig functions. Like cosine and sine waves are the same fucking wave, just shifted. We saw the graphs of hyperbolic cosine and sine, they don't look anything alike. I don't understand how all their trig functions work together so fluidly, but maybe it's just that's how we define them. And this one leads to your variant forms. If you divide by cosh, you get 1 minus tanh squared theta equals sech squared theta. And if you were to divide by sinh, you get cosh squared theta minus 1 equals the hyperbolic cosecant. These look just like our other two trig identities, but they have a minus rather than a plus. If it helps you to remember which one goes first here, we usually associate cosine with X and sine with Y. It's no different here. Fucking lights just cast a glare. We've got our sinh A plus B. Sinh A cosh B plus cosh A sinh B. And the same is true with the minus. You put the minus in there and it just makes it minus. Cosh is set up the same way. We can do A plus or minus B. And this one is cosh A, cosh B. Plus or minus sinh A, sinh B. And this one's a little different than the regular trig one. The regular trig one uses the opposite signs. This one uses the same sign. Plus goes with plus. There we go. Need a little bit of tuning. You'll see if you make them both A's, sinh of A plus A or 2A ends up being 2 sinh A cosh A, like your sine of 2 theta formula. And cosh of 2A, a little bit different than your other one. We've got cosh squared A minus sinh squared A. No, plus. That's how it's different. Because A plus A gives us the plus one. When you do cosine of 2 theta, this one has cosine squared minus sine squared. And cosh has plus. So slightly different. Two more things before I let you get caught up. Cosh x is an even function. So that cosh of negative x equals cosh of x. And sinh of x is odd. So that sinh of negative x equals negative sinh x. Yeah, I gotta say, when I was a Calc 1 student, I think they told me about even and odd functions, but it's very little. They ended up helping a lot with integration. Because like if it's an even function, you only have to integrate half if you're going down line of symmetry. Like if you integrated y equals x squared, you could just do 0 onward rather than. Like if you're going from negative a to a, you could only do 0 to a, just double it. But that doesn't go on this topic. More is more of a tool that helps you later on when you have this stuff down pretty well. Let's prove that one. Prove cosh of a plus b.
Professor,
Yeah,
what's the one on the very far right side with the sine 2 theta and cosine 2 theta?
these are the basic trig functions. These are the hyperbolic, these are the basic
Oh, yeah,
cosine
yeah.
squared minus sine squared. I was showing that they're similar, but this is minus and this is plus.
Got it.
And the sine of 2 theta looks like identical to the sinh, just a different, got an h in it. So this is cosh A, cosh B. Plus sinh A, sinh B. Let's start with the right side. That's probably the easier way to start. So cosh A is, I'll do my A's in blue and my B's in red. So cosh A is e to the A plus e to the negative A over 2. And then cosh B is e to the B plus e to the negative B over 2. And maybe I should put these in parentheses. It looks like we're going to have to distribute. Then I have my sinh ones, e to the A minus e to the negative A over 2. And e to the B minus e to the negative B over 2. Now this is gonna fuck with most people's head, but just a quick reminder, if I had x squared times x cubed, what would I get? X to the 5th power, right? We add exponents. So that's what we're gonna do when we distribute. So all of these are gonna have a 2 times 2 on bottom. Let's save ourselves a lot of fraction work and just write the 1/4 out front. How's that sound? If you want to keep writing 1 over 1/4 or over 4. Now, if we do FOIL here, we've got e to the A times e to the B, we've got e to the A plus B. If I do outside, e to the A times e to the minus B is e to the A minus B. And I'm going to keep them in the same letter order. If I do inside, I have e to the negative A plus B. And if I do last, I have e to the negative A minus B. That's from my first set. Everybody buy that so far? Just a little bit of algebra. We'll do the same over here. We've got plus e to the a plus b. And now I do outside, I have a minus e to the a minus b. If I do inside, I have another minus and then e to the minus a plus b. If I do outside, it's positive again, e to the negative a minus b. What's the issue? Well, this is a minus b and this is a minus b and they cancel. As does the negative a plus b. That one cancels that one. And then I have e to the a plus b here and e to the a plus b here. Those add together. I have 2e to the a plus b. I still got my 1/4 outside. And then if I do the minus a and minus b, I have 2 of those. And what I'm going to do is I'm going to factor out the negative out of the exponent so it looks like this. Push the 1/4 in, I've got e to the a plus b plus e to the minus a plus b over 2. And if you don't see it yet, just treat u as a plus b. And we have e to the u plus e to the negative u over 2, which would be cosh u, which is cosh a plus b. The idea of proving it before I started writing down e to the a, e to the negative a probably sounded a little bit overwhelming. Like, how the fuck are we going to prove that? Most of the stuff in this, if you wanted to prove it, you can just go back to the equations that have x in them. And you do some algebra manipulation. I'm going to write here RHS, which stands for right-hand side. And now here we have LHS, or left-hand side of the equation. Any questions so far? Are we having fun yet?
Of course.
That's the right answer. I have a kid in my, kid is not the right word, 18-year-old in my pre-calc B, which is the trigonometry class. He walked in, he's like, Good morning, Professor. Isn't it such a wonderful day? It was like 8 to 10. It's an 8 to 10 class. He said this on Monday. I'm like, well, I don't know yet. It's still early, but that's sure as hell sounded sarcastic. He just wants to get like, he just wants to repair computers. He's like, I need a piece of paper that says I can repair computers. I'm like, I'm pretty sure you can go to like a computer like repair place and they'll hire you if you can just show you can do it. You don't need a degree for that. And he's like, I want to work for a big business. I like a big business. You're not repairing computers very often. There's no like corporate repair your computer here. Like the closest you get is like the Geek Squad for Best Buy, right? But that's not what he had in mind. It wasn't sales. And I'm like, well, you should show up and like even if you don't know why you're like, I don't know why you're at college. Parents told me I need to come. I'm like, okay. I hope you find the motivation in within yourself to another reason to come, because I have yet to see a student do well long term where that is their driving force. Eventually, you're like, I could fucking move out and get a fucking part-time job or a full-time job. Anything is better than staying in school longer. Generally, that's the mentality of someone that's doing that. So try to find something fun. He said he's like, I already know all this stuff. So it's like, this is an exciting one. Like, why are you in here? He's like, because I didn't take a class on it. I'm like, you didn't? No. He's like, no, I was curious about the topic. So I was watching like the video sequence on Khan Academy. I did a bunch of other math stuff too. I'm like, if you haven't, I don't know anybody that just goes out and watches fucking math videos for fun. Not even me. I don't go do this for fucking the hobby. I'm like, you have a fucking interest in math. Maybe you should keep that in the mix. We'll see. That ramble was to give everybody time to catch up. It looks like everybody did. All right. Nope.
What's the last box at the bottom right?
LHS stands for left-hand side. We were
Left-hand
proving
side.
that's this
Oh,
side.
okay.
We started with the right-hand side. We ended with the left-hand side.
Okay.
All right. So isn't it wonderful that the hyperbolics tie into the exponentials? That's pretty fucking great. So do the trig functions. Euler and Euler's formula. And yes, it's pronounced Euler. Not Euler. I thought it was Euler for the longest fucking time. And then someone called it Euler. I'm like, who the fuck is Euler? E to the plus or minus I theta is cosine theta plus or minus I sine theta. So we could write cosine theta as e to the I theta plus e to the negative I theta over 2. And sine of theta is e to the I theta minus e to the I theta over 2. And that's your relationship between trig functions and complex exponentials. Yeah. Thank you. Yeah, if they were both positive, that would be 0, right? Good call, Dalton. We're not going to do anything with that. It just felt like a good spot to tie it in. It will show up in other classes later on.
relationship. That's like they just made it up, it's almost imaginary.
Feels like it, right? This is how alternating current relies on complex numbers. They'll use J over in engineering now. They don't like I. I is reserved for amps. It's in electricity. So they use J for complex numbers. All right, so that's all the boring shit, like what everything is. This is a calculus class. Let's talk about derivatives. And you could work backwards for integrals. Let's just look at our two base ones. We'll take the ddx of cosh x. That's ddx e to the x plus e to the negative x over 2. E to the x doesn't change. E to the negative x brings the negative down, but then doesn't change. And that's cinch. Why don't you guys do the derivative of cinch x? Give it a try. And then if that was too easy, and it probably was. Yeah. Tanh. And I'll rewrite what that is. Euler's formula, I want to say, becomes really useful when you take differentials. Assuming you take differentials. I know, I think engineering degree stops at Calc 3, but if you do 2 more math classes, you have a AA in mathematics, and you know a shitload more. That's actually helpful in all the physics stuff. Because you do differential stuff in physics. I recommend doing the full math sequence for all of you guys. So we should see that first one again stays the same. We bring the negative down on that one, becomes positive. Over 2, that's cosh. That one was easy. That was a super easy one. I'd be surprised if anyone's done with hyperbolic tangent yet. So keep going. Get her done. Don't just let, y'all know how to do derivatives?
I got a derivative, I just only think it's right.
Do you have a hyperbolic trig function for it?
1 minus 1, yeah.
Huh, I don't remember if it has a 1 minus 1. We'll see. You might. I don't know, we'll find out. Giving everybody a moment.
I think after you said that, now I'm rethinking my answer.
Well, there is one that works. What do you have? 1 minus what?
And H squared.
Yep. You're almost there.
Simplify that further. Oh,
I already gave you the formula for it too. So Michael, did you do this as a quotient rule or as a product rule?
quotient.
Y'all know you can do a quotient rule as a product rule, right? I mean, this is effectively the same thing as ddx of e to the x minus e to the negative x times e to the x plus e to the negative x to the negative 1. So like a product rule with some chain rule going on. We'll go quotient rule though. So we got what, low d high minus high d low over low squared. So low is e to the x plus e to the negative x times the derivative of the high, which is e to the x plus e to the negative x minus high times the derivative of the low. That's convenient. All over low squared. Now, if you want to do this the hard way, you could try to multiply this out and figure it out from there. But if I separate this, this is on top, the first set is e to the x plus e to the negative x squared. And that's what we have on bottom too. That's convenient. And we have minus, those are squared, e to the x minus e to the negative x, e to the x plus e to the negative x. And I'm going to put the square on the outside here. They're both squared, so I can move the square outward. This is 1 minus, that's the formula for tanh x, and it's squared. And that is sech squared. That's like you're killing me, bro. This is too fucking easy. No? Did you not get it?
I got to 1 minus tanh, but I forgot it was.
Forgot.
Yeah. I mean,
That's a natural spot to forget. So let's make a list of all of them without all the fucking bullshit in the way. That's kind of what you want. You're like, I don't want to have to go through my notes for all this shit. So ddx of cosh x is sinh x. And ddx of sinh x is cosh x. Notice that neither have sign changes. Normally, when you take the derivative of cosine, you get a negative in there. Not today. Not with the hyperbolics. Then we got our ddx of tanh. These all look familiar. Like basically, they look like they're trig equivalents, don't they? It's fucking. It's almost creepy. We do ddx of coth Need an H there. It's the hyperbolic cosecant one squared. This one does have the negative. In fact, the remaining three have the negatives. All your inverse or your flipped ones have the negatives. So if we do spatial derivative of secant, this is the secant tangent. In regular like trig functions, it's positive secant tangent. Here it's negative. And we do hyperbolic cosecant. We get negative hyperbolic cosecant cotangent. Those are your basic six. And you can always integrate to go the other way. Integrate both sides with respect to x. Or the integral formulas. And don't forget your constant of integration. If you don't have limits. And with that, let's take a 10-minute break. That was a lot of shit to pack in there. All right. Before we go to the inverse hyperbolic trig functions, let's give you some shit to do for some practice. Integrate cosh of 5x minus 7 dx. We got the derivative page up. That should be good for you guys. Let's see. Discord. Put it in her session. Someone remind me tonight to put a link to the free trig practice. Well, if you do a u sub, u goes 5x minus 7, du is 5 dx. So we got 1/5 du equals dx. So I'll put my 1/5 outside. I've got cosh of u du. The beautiful thing with cosh and sinh is they're just the other one with no sign worries. So this is sinh u plus c. And we will replace that with what u was. Ooh. Ooh. Integral of x tanh x sec squared x dx. The fuck is this madness? Nope, there's more in it. It's gotta have an x squared inside. Make these x squareds. You're not gonna be able to solve it without that. I'm like, something looks off. You know the good thing? There's more than one way to fucking do this, some bitch. Have you done this problem? Yeah, it's a good problem. Anyone got any ideas? All right, so Dad said, let's try this one. U equals tanh x squared. So if we do that, du is hyperbolic secant squared x squared times the derivative of the inside times dx. And we have the x and we have the secant squared. So all I need to do is move the 2 to the other side. 1/2 du is x secant squared or hyperbolic secant squared x squared dx. And I have 1/2 the integral. This gets replaced with u du. Am I missing anything? Doesn't look like it. Up a power, divide by the power. 1/4 u squared plus c, or 1/4 tanh squared x squared plus c. What if we had said u equals secant of x squared? Du is negative secant tangent. And then we have the 2x dx. So this has everything that we need except the -2. I would have -1/2 du equals all that good shit there. X secant x squared tanh x squared dx. And this becomes the integral of -1/2 u du. right?
It would be script, this is the. CK. Yeah,
Well, it's not,
no.
no, because one of them is eaten up in the derivative.
Yeah.
It's just you. Because we gotta use one of these is for the u, the other one is eaten up right here. So we get -1/4 u squared plus c. So -1/4. Secant squared x squared plus c. What? This is bullshit. Those look drastically different, don't they? There is a function that relates them though. And maybe it would help if I put C1 and C2 here to point out that those constants are going to be different. If I throw in a 1/4, wait, which one has it? We had 1 minus tanh. Yeah, if I put a 1/4 here, I have 1/4 C2 equals 1/4 plus C1. I've got C1 plus 1/4 times 1 minus c squared x squared. And that gives me my C1 plus 1/4 tanh. So we can connect the two, but there was more than one way to solve it. That's kind of neat. Okay. Let's do one more. We're gonna integrate, we'll have limits of integration on this bad boy. We're gonna go 0 to natural log of 3. We're gonna do e to the x minus e to the negative x. Thank you. And we'll do over e to the x plus e to the negative x dx. Give that bad boy a try. What hyperbolic identity is that? Does it help you? Kind of want it to, don't you? We've been doing hyperbolic shit. But we want to end, that would mean integrating tanh. Do we have anything that going backward is we're like tanh was the answer? No, that's what we call a red herring. Don't go down the wrong rabbit hole. Do not switch to hyperbolic here. I mean, you'll figure that out right away. So you're like, I don't know what the hell to do. If I switch it, I don't know what to do. I can't integrate this. That's pretty cool. Most of you guys are actually using notebooks, not tablets. I don't feel so old anymore. You know what? I think during this 3-day weekend, I'm gonna pull out my old Calc 2 notebook. I'm pretty sure I have it in a drawer. When I was a student here. Do you know how fun it was to come back and tell my teachers I was but the learner, now I am the master? Do you know how fucking satisfying that was? How many people know that reference? Probably not all of you. That was fucking satisfying.
I remember like a
Yeah,
month
it's
or
like
so.
almost as old as I am. Star Wars came out when I was a child.
There was from Star Wars,
Yeah,
because that's what I
that's
remember.
Darth Vader.
I thought it was older, the saying.
No, that's Darth Vader to Obi-Wan.
I did remember it.
Yeah, number 1/4 if it's a count.
Yeah, episode 4. Right before he cuts him down. Spoiler alert. Don't get any fucking ideas. Don't try to cut down your teacher. Not even if you pass him in degree or reach him with the same rank. Don't come back and try to kill me or any of your teachers. Just come back and like quote Darth Vader. Not if you don't kill me. In fact, I am waiting for a student to email me that. Send me a picture of like a master's degree in mathematics. And just send me a picture and just fucking single quote there. All right, what do we do here? Help me out, water polo.
I don't think I did it right at all because I got stuck. So
Well, what did you try?
I tried switching it to. You know, I look back in the notes. The. E to the x plus e to the negative x over e to the x plus e to the negative x squared minus. That. It's the sec squared, but the longer.
Oh, okay.
But that's why.
Yeah, that's the hard way. What is your name?
Brett.
Brett. Yeah. Still learning everybody's names. Can't call you water polo all the time. You wouldn't respond to David Griffin. Even though that, I think that's who you remind me of. I really do. Anybody else got another try? That seems like a hard way to go.
I just multiplied the bottom, the denominator, trying to get it into just not being a fraction.
How did you do that?
I multiplied the ex plus e to the negative x. Basically multiplying by 1. Trying to get rid of the fraction.
Did you get rid of it? Like, I don't know how you do that and get rid of it. So,
So I could get rid, so it wouldn't be a fraction.
right, but were you able to do that? Because I don't know how you would do that.
I think so. It's correct.
All right, anyone else got another idea? They're always worth exploring ideas.
So?
What kind of you sub?
E to the x plus e to the negative x.
Let's take a look. What's du here? I'm gonna put that in parentheses. Because we would really have a dx on each of these. But I'm gonna factor the dx out. So if I wanted to redo the limits, what do I have here? When x equals 0, u equals e to the 0 plus e to the negative 0 is 2. X equals natural log of 3. U equals e to the ln of 3 plus e to the negative ln of 3. What do we get? What is this one? That's 3. What about this one? That one ends up being minus 3. We can pull the minus down first and then the EL. So 0. So our limits switch to 2 to 0. Nope. Yeah, 2 to 0. And I've got 1 over u du. Now, as a reminder, and this is a great one to show it on, we can switch the limits of integration if we incorporate a negative sign. I'm pretty sure you learned that in Calc 1. This is a great one to show it on though. Like if I do the left side through, this integrates to the natural log, rut row, natural log of u. This causes a problem. Because of the 0. Natural log of 0 doesn't exist. DNA. In fact, it caused a problem up here, didn't it? You put ln of 3 in here. Did we do this step right? Now that it's making me wonder if we did this step right. We didn't do the step right. This is definitely 3. This is 1 over e to the ln of 3. So that's 3 1/3. So that's not 0. So that was wrong. We still had the ln of u. From 2 to, we'll go 10/3. So ln of 10/3 minus ln of 2. You can leave it like that. Limit or the rules on natural logs, we can combine those. This is 10 over 6 or 5/3. We'd have to change that limit there too. But now there's no reason to. They were already in the right order. I like the -3 also. In my head, that looked right. But as soon as we fucking plugged it in, we saw that shit wasn't right. Real quick. All right. Inverses. So like if we have y equals cosh x and we do the inverse, we swap the letters, right? That's how we find inverse functions. And I could write this as y equals cosh inverse x. But I'm gonna play with this one. Let's work with this one. X equals cosh y, that's x equals e to the y plus e to the negative y over 2. And if we clear fractions, we've got two x equals e to the y plus e to the negative y. And we already saw leaving it as a negative kind of like bucked us up last time. So maybe let's rewrite it as without the negative exponent. If we multiply through by e to the y, we get two x e to the y equals e to the y squared plus 1. And if I put everything on one side, e to the y squared minus 2x e to the y plus 1 equals 0. And you might be thinking, where the fuck is he going with this? What the fuck is he doing? Why? You'll see that the hyperbolic functions can be written, or the inverse hyperbolic functions have values that are non-hyperbolic. Dun, dun, dun. What can I do here? What form is this equation? I see mouths moving, but no one's saying it loud enough for me to hear. Does it help if I put parentheses around this? Your algebra is not as good as you thought it was. I have something squared, something that's just to the first power and a constant. This is quadratic. Which means I can do a u sub, u equals e to the y. And this turns into u squared minus 2xu plus 1 equals 0. And like this is the whole b. So like we can't factor, we're gonna have to do the quadratic formula. So u, which equals e to the y, equals negative b, which is positive 2x, plus or minus b squared, which is negative 2x squared minus 4 times 1 times 1, all over 2 times 1. If I clean that up a little bit, I got 2x plus or minus the square root of 4x squared minus 4 over 2. And that is square root of 4 times the square root of x squared minus 1. So u, which is e to the y, equals, I've got 2 times x plus or minus square root of x squared minus 1 on top, 2 on bottom. The 2's cancel. e to the y equals x plus or minus square root of x squared minus 1. How do I get it where it's just y? What? Take the natural log. I like that. Take the natural log of that one, take the natural log of this one. I get y, I'll do this on the next page. Rather than trying to squeeze it in. I'm on screen. Y equals natural log of x plus or minus x squared minus 1. Yeah, we don't leave it like that. We're gonna do a little bit of manipulation. If I look at the x1, x minus 1, if I have this and I multiply by the conjugate, I get x squared minus x squared minus 1. Which is just 1 over x plus square root of x squared minus 1. Did you want this on your test now? You sure? You want it on homework? I'll assign some for you guys to do, but I wouldn't like do it like after the test and you're waiting for the next Monday to roll around. If you want to practice it, don't like do any of the homework for the test for 6.9. I got to pick some problems for you guys. So this would give me two answers here. Y equals natural log of x plus square root of x squared minus 1. Or y equals natural log of 1 over that. Oops. But this is just natural log of 1 minus natural log of x plus square root of x squared minus 1. Or you treat it like a exponent. This is 0. And now I've got the negative version of that one. Y equals plus or minus natural log of x plus x squared minus 1. By convention, we ignore the negative branch. So we're going to say cosh inverse x, because that's what y was here. Cosh inverse x equals the natural log of x plus square root of x squared minus 1. And this is where we'll start making our table. I'm not going to go through the walkthrough for the rest of them. They're all somewhat similar, but somewhat different. I will say that this has a domain of 1 to 0, or 1 to infinity, 1 to 0, and a range of 0 to infinity. So D is domain and R is range here. I'll pause for a second for you guys to finish writing that shit down. We got 5 more to do and we gotta write the derivatives too.
I had a question, do we need to memorize this ones for this test?
Nope, it is not on this test. It's not gonna be on the next test. I don't think I'll have it on any of the tests. It just doesn't come up often enough for you to, like, you saw how many fucking formulas there were. This is a lot of shit to pack in to memorize for something that's hardly ever used. Just, and this is how life is, you're now going to be aware that it exists. And that is fucking more than half the battle. Because you'll go, that looks fucking pretty ugly, but this reminds, this, you might see something that goes, that looks fucked up enough that I bet there's a formula for this. Some of them we'll see when we do them in a second, you'll be like, yeah, it'll trigger an idea when you see it. And you won't remember what it is, but you'll know that you can look it up. And in today's day and age, that's as quick as that. Just type it in Google and bam, take a fucking picture, bam. There's apps that do it. I know there are. All right, so that's Kosh. Cinch. Cinch inverse of X is similar, very similar. It's X plus the square root of X squared plus 1. The only difference is the sign inside the radical. But it does have different domain. Both domain and range are infinite. It's the full spread of numbers, negative infinity to infinity. So our tangent here. This is fun. 1/2 natural log of 1 plus X over 1 minus X. Isn't that a hoot? No, that I'm not old enough where that's my common lingo. I'm old, but I ain't that fucking old. The domain here is -1 to 1, not including either of them. And the range is infinite. Most of this is just having seen it and knowing that I can look that up later if I need it. Coth or inverse or the 1/tang inverse looks very, very similar to the tangent. In fact, it's X plus 1 over X minus 1. Negative infinity to -1 in union with 1 to infinity. And this one's the worst one. Negative infinity to 0 in union with 0 to infinity. All right, cinch goes with cosecant. I'll do that in green also. Cosecant inverse. What is this one's formula? Oh, you're gonna love this one. Natural log of 1/x plus the square root of 1 plus x squared over the absolute value of x. How about them apples? Who wants to memorize that with me? No? No takers? Just a disappointing class.
That's the edge.
Shit, that's domain and range. Range is also that. And we're missing one, we're missing one over cost, so secant inverse x. What is this fucked up formula? It's like the cosecant, but it doesn't have the absolute value. It's slightly different. We're not doing the absolute values, so we can put them together. The radical has a different sign underneath. It's like that. And this one has a simple domain and range. Domain is 0 to 1, not including 0, but including 1, which is weird. And range is 0 to infinity, including 0. Six more. The derivatives. Are we having fun yet? Brett's like, fuck this class. Fuck this class right in his goddamn neck. I'm not testing you on this. Is that not worth the mercy? I'm just making you look at it. I'm not pulling an evil birch and making you pull the rabbit out of the fucking hat. Did you have to do this on yours? No. That explains why she didn't try to ask me why I'm not making you do this. She did ask why I wasn't having moments, covering moments and making you do that. I'm like, moments is so fucking rarely used.
Do you know if Brennan still does that or adds that to his tests?
I don't know about John, but Tracy has moments on our test.
Because I slightly remember. It was painful.
It is painful, and you're not gonna fucking use it again for 8 months, and then you'll never use it again after that unless you're going into fucking teeter-totter physics. It's what moments are for. It's on like where the pivot is and how you rotate. I'll make a video for you guys, but like just so you can like have it available. So when you get to that point in Calc 3D where we gotta cover it. All right, derivatives. ddx of sinh inverse. 1 over the square root of 1 plus x squared. The inverse, the integral of this shows up a fucking lot. I would argue that this one is worth memorizing. Comes up more often than you'd like. I know that. I bet Kosh does too. I think all the basic 3 here do. This is 1 over the square root of x squared minus 1. And we require x to be greater than 1 here to be in a domain. And a spatial derivative of hyperbolic tangent. I think it's 1 minus x squared on bottom, I think. It is. How about that? This is a fun fucking restriction. Absolute value of x is less than 1. So this is only good from -1 to 1. I think the inverse ones come up more often than the regular ones, to be honest. Let's see. We did sinh first, so we'll do hyperbolic cosecant. This is the fun one. -1 over absolute value of x times the square root of 1 plus x squared. And we require x to not equal 0 here for, actually, it's apparent, obvious reasons, it doesn't work in the derivative. This one looks so close to cosecant, but it dumps the absolute value and it has a negative sign in there. 1 minus x squared. With a different range as well. 0 is less than x, less than 1. And cough. It's 1 over 1 minus x squared, which is nice. And we require absolute value of x to be greater than 1 this time. So it's just like the hyperbolic tangent, but the opposite domain. And contrary to what Big Bang Theory will tell you, this knowing this shit will not help you get laid. It doesn't matter if you're male or female. No one's impressed by this shit. But if you do have it memorized, it does help in some sort of situations. You will see integrals of some of these things more often than you'll see. Let's see, what do we have for the other ones? No, these are the only ones we had the equivalent without the trig functions. You don't see the e to the x plus e to the negative x very often. That shit just doesn't come up. I will have a practice exam loaded for you guys soon, hopefully tonight. Ainsley's got her practice exam with her solution set. Is that can they see it or is that just hidden? Okay, she's got it up on her Discord. So if you haven't joined her Discord, I recommend you do join it. Like you can see, try her exam and then look at the answer key. You can try my exam and look at the answer key. And if you do both tests, you're ready for the exam. There is an area between curve. You know, the one difference between mine and hers, I have arc length on there as well. I have an arc length problem and one less disk washer problem. There's a disk washer problem. There's find the area between two curves. There's a disk slash washer. There's a cylindrical shells. And they're the same one, so you can see that you get the same answer. There is an arc length. There is a surface area of revolution, which is basically uses the arc length formula. And then a work problem, 6 problems. You'll see what they are when I put them up.
In this one at the time.
You're welcome.
Oh, I didn't think test only was 45 minutes long. It was 10 problems.
And only 45 minutes?
Yeah.
How?
Or no, that's 6.
I don't know. Jared, Mr. Birch only gave me 45 minutes to take the test.
That's how long the test was. The class was, and he has another class after.
Wow, and 10 problems, that's a rush. Because these you have to end up doing
That's not 5
easier
minutes.
problems.
That's not 5 minutes a problem. That's.
No, it's,
4
yeah. So you have to do easy problems. That's a rough call
It
right
was
there.
a morning class, and now almost always arrive late, so I have to leave.
That is ridiculous.
I gotta look at what, cause mine were only 1 hour classes each and I took Calc 2 here. I don't have to, I really gotta pull mine out this weekend and see what I had.
Over the summer, it was 3-hour classes. So it was like